Okay, now to do the vector revision test. First question is this one here, and we need to write vector B in terms of ADC. This is vector B going down, and to get vector B, that means we have to start at the tail and work around to the arrowhead. So to work around that way, we have to go against A, against D, and with C. That's why it's minus A, minus D, plus C. If you want to do B in numerical form, we have to look at the components. So we're going from 6, 5 up to 9 minus 4, and we do final take initial. So 9 take 6 is 3, minus 4 take 5 is minus 9. That's the vector B from C to D. Write vector B in terms of I and J. The I vector is the 1, 0, the unit vector along the x-axis. The J vector is 0, 1. Now, the same way as getting the vector 3 minus 9, that is just 3 times that unit vector minus 9 times that unit vector. Now that's called I, so it's 3I, and that's 9J. So therefore we get this alternative way of writing B. So we can see there are 3 ways here of writing the same thing. These are all vector B, 3 different ways of writing the same vector. If we want the magnitude, which stands for the length, then we use Pythagoras. The reason Pythagoras works is because if we look up at B, what we've worked out is that it's 3 across and it's 9 down, because it's minus 9, 3 comma minus 9. If we want the length of that triangle, we just use Pythagoras, the square root of 3 squared plus 9 squared, which is root 90. If we want the direction of that vector, that's the angle sitting in here. You can see the diagram redrawn down here. So we've got to use tan theta is 9 on 3. Do shift tan, you get 72 degrees. We could say, to quote it properly, we should quote it from the south line, so it's south 18 degrees west, or you could actually do it from the true north line going around that way, in which case you'd add on 90 to 72, so that'll be 162 degrees true. That's another way of writing it. F, find all unit vectors parallel to B. Parallel to B would be something which is with B or against B. They're both parallel, but it has to be length 1 because it says unit vectors. So actually this is wrong. It shouldn't be a multiple, it should be plus or minus this unit vector. To get the unit vector, you get the vector 3 comma minus 9, you just divide by the length. Dividing by the length will actually make it a unit 1 length. And plus or minus means it goes with or against the direction of B. Find all vectors perpendicular to B with length 5. To get something that's perpendicular, we have to get the original vector, 3 minus 9. To get a perpendicular vector, we swap the components and we change the sign of one of them. So minus 9 could become plus 9. The reason why that works is, one way of thinking of it is the dot product. Dot product, if it's 0, then you have 90 degree angle between them. 9 3s are 27, so we get 27 minus 9 3s are 27, which is 0. So that's why it works. Another way to think of it in terms of slopes, if you look at 3 minus 9, what that means is a run of 3 and a drop or a rise, which fall of 9. Now that's equivalent to talking about the slope. The slope is rise on run, so it's 9 on 3. If you want something perpendicular, you have to flip that upside down and negate it. So something perpendicular to that would be a slope with 3 on 9, which is what you learnt in year 10, perpendicular slopes. Now 3 on 9 is that's rise on run, so that's this vector here. So that's what these two vectors here similar to these two slopes here. These two slopes are perpendicular, so therefore these two vectors are perpendicular. So all vectors perpendicular would be this one here. That's a unit vector, but so we have to times by 5 because we need length 5. Show geometrically D plus B. So that is D plus B will be that one, that's D, and that's B. Adding two vectors, you've got to go tip to tail. So this is the tip of D, and this is the tail of B. So it's almost like starting there and finishing there. So that's D plus B. Instead of going around the outside, D plus B is the quick travel vector from the start to the finish. That's showing it geometrically. It asks you to repeat it, D plus B, in numerical form. To do it numerically, you just write D and B down, and you can get that from the top diagram by subtracting the final points from the initial points. And if you add those two, you get 7 and 3 is 10, 0 minus 9 is minus 9. So that's the other way. Find P, which divides CD in that ratio. So here's CD, C to D, and P divides it. We've got to make it closer to C because it's 2 is to 3. Now to find point P, we can say point P equals point C plus 2/5 of the vector CD. There are 5 parts there, so it's 2/5 of the way along. So C plus 2/5 CD, there is our coordinate for C. There is our 2/5 for 2/5, and the CD, there's our vector CD. If you do 6 plus 2/5 3, you get that. 5 plus 2/5 minus 9, you get that. So that's our point P. Now I'll just plug my electricity in. All good to go. Alright, calculate the angle DAB using the scalar dot product. DAB is sitting here, that angle there. So we want to dot that vector with that vector. We always have the vectors with two tails heading away from each other when we dot them. So the dot product is equal to CD cos theta. Now we know the numerical way of doing a dot product is you do C1 D1 plus C2 D2. So that's this vector times that vector, C times D, and we do C1, which is that, times D1, which is that, so that's that one, plus C2 times D2, 0, and well, that should say 9 there. 0 times 9, which is 0. So that's minus 7, which is here. On the right hand side, doing the other way of doing the dot product is using length cos theta. The length of C is 7, the length of D is root 82 using Pythagoras, and the angle cos theta we leave like that. We're trying to find theta. This thing here we now take over the other side, so that comes over to the other side on the bottom, and now we do shift cos and we get 96 degrees. So that's the angle between those two vectors. Calculate the projection of C on D. The definition is this here. That's the projection vector of C on D. So we've already done C dot D above, and that was, you can see here, minus 7. So there it is there. Divide by the length of D. We've done that. That's sitting up here as the length of D, and this is the vector D divided by the length of D again. So length of D is appearing in two places. Root 82 times root 82 is 82, and so that's simplified. Now we have a application, ship travelling east 10 knots, then there's a Gulf Stream going southeast 5 knots, and we have to draw the vector diagram to represent the ship's velocity and determine the ship's velocity using either of these two methods here. So I've done both methods. The first method is using cosine and sine rule. So we've got to use x squared equals, it's a squared plus b squared minus 2ab cos of the angle between them. That's the cosine rule. If you solve that, you get 13.99. The sine rule, to get the angle, sine A over A equals sine B over B. That's what we did in pure A maths. Rearrange that and then inverse sine. So it's 14.6, but from the south, you say south 75 degrees east. The other way of doing it is you can use vectors. So the ship's velocity, because it's going 10 knots to the right, we can say it's 10, 0. The water stream, 5 knots southeast, we can say it's 5 cos 45 and minus 5 sine 45. And the reason is because we've got 5 coming down like this, and we're splitting it into two components. This is theta, so this is 5 cos theta, which is, and the theta is 45, and this side is 5 sine theta. Because it's going down, we put a negative there. So that's where this is, except with thetas we're just putting the 45s in. Now we can add these two vectors, s plus w, and so we've got 10 plus that, and we've got 0 minus that. Put in the calculator, we get those two values. To get the length of that, we do Pythagoras with these two, square root of that squared plus that squared, and you get 13.9. And that agrees with the value we got up here, 13.9. To get the angle, we just have to do tan theta and then shift tan, and we get 14.6, which also agrees with that one up there. Question 3, find the angle between two vectors. First of all, we need to get the vectors, and we get that from the slopes. So the slope of this line, you can say it's y equals mx plus c. So the slope is 3, and we say it's 3 on 1, and that's rise on run. And when you write a vector, it's always the run, comma, the rise, because you write the x first and the y second. So that's why we can write a vector in the same direction as this is 1, 3. This one here, 2x take 3, you could rearrange to get into y equals mx plus c, or you could use the other method, which is ax take by equals ax1 take by1. The slope is a on b, and so if you see here, it's just 2 on 3. Because there's A, there's B, 2 on 3. So if the slope is A, 2 on 3, that means the run is 3 and the rise is 2. Alternatively, you could have done the other way and rearrange that to get y equals mx plus c, but this is quicker. Now we dot the two vectors. v1 dot v2 is the length of v, length of v2, cos of the angle between them. To dot them, we go 1 times 3 plus 3 times 2, so that's that. The length, we can get the length of vector 1, length of vector 2 using Pythagoras and cos of the angle, rearrange it, shift cos it, and so we get 37.9 degrees. The last one is a proof question. So we've got a circle centre 0, diameter AB, and there's a chord AC. The midpoint of that is D. So that means we can draw a line there and a line there to say they're equal lengths. OA is vector A, that's that way. OC, which is this one, that we're calling C. Right, in terms of A and C, the vectors AC and OD. Okay, AC is going this way, so that's going sorry, let's do it again. It's asking for AC first. So AC is this big one going up. To go from A to C, we've got to go against A and then with C. So it's minus A plus C. If we want OD, OD, that's going from this point here over to the middle, O to D. Then I'll just clean this up a bit. Okay. If we're going from O to D that way, then we need to go OA plus AD. And OA is A, vector A, so that's that one there. And A to D, we know that A to C, we've worked out already in up above, that's that value. But A to O is half of that, so it's going to be half of A to C. And then we've put in what we found up here, so it's half of that. And now if you expand that, you'll get half A and half C, which you could take out a compactor of half then. Use vector proof to show OD is perpendicular to AC. So we want to show that this one is perpendicular to that. So obviously to show perpendicularity, we dot them and show it 0. So we've got OD above, we've got AC above. If you dot them and expand that out, you'll get 0, showing that they're perpendicular. Notice that A dot A is A squared and C dot C is C squared. These cancel out. This is foiling. First outers, inners last. And the two dot products, these dot products are A squared and C squared, because if you dot A with A, that's length A times length A times cos theta, because the angle between them is 0, that's 1. So it's length A times length A, which is length A squared. Now we've got two chords, PQ and QR. Show on the diagram how you could use the midpoints of the chords to find the centre of the circle. So we need to find the centre of the circle from these two midpoints. The midpoint of PQ is averaging the x's and averaging the y's, so that's 2. The midpoint of QR, average the x's and y's, and we get 5, 3. Now we can get the slope of PQ by doing y2 take y1 on x2 take x1, and so that would be 6 take 3 on 4 take 0, so that's 3/4. Likewise, we can get the slope of QR being -3. Because we've got the slopes, we can get the vectors. If a slope's 3/4, that's rise on run, we do run followed by rise, run followed by rise. We've got the two vectors now. Now I've just redone this, so we've just come from working out vector 1, 4, 3 and vector 2, 1, -3. These are the vectors going that way and that way. To get the perpendicular vectors, we have to swap them around to 3, -4 and 3, 1. So you swap them and you negate one of the components. They now represent vectors perpendicular. Now we want them perpendicular so that we can meet in the middle somewhere and in the center. So to find the center, we can now say it's going to come from the midpoint 2, 4 plus a multiple of that first vector, perpendicular vector 3, -4. And the other one is going to come from the point 5, 3 plus a multiple of the vector 2, perpendicular 3, 1. So if we make those two equal, then we're saying that they have to hit the same point, which turns out to be the center. And then we solve that equation. So it's the x plus the x equals the x plus the x coordinate. So that's what all of this is. 2 plus 3k equals 5 plus 3l. And you rearrange that to get equation 1. And then the second equation comes from the y. The y here, and the y there, and the y there, and the y there. So it's 4 take 4k equals 3 plus l. 4 take 4k, this one, equals 3 plus 1l. And so that's equation 2. And now we rearrange that to get l, and you substitute l, the value for l, into l for equation 1. So sub 2 into 1, and we get that equation, and you just solve for k and l. So the center turns out to be that, and well, that's the k and l value,
And so if we want the center, we can now just grab any of those. We could just grab the original one there. So it's 2, 4 plus 6/15, that's the k value, of 3, minus 4. And if we do that, we'll actually get the center. So it'll be 2 plus 18 on 15, you can work that on the calculator, and 4 plus minus 24 on 15. And so that's one way of working out the center of the circle.